This is 5.5 part 2. We're going to finish example 1 that we started in the previous video. So remember, we were trying to see if a truck could fit through a bridge that formed an arch. We had drawn our truck in, and we found the truck was 5 meters wide, and that in the middle it should be fine because the height's 7.5, and the height of the middle here at the highest point is 10.8 as per our question. Now what we're worried about is that, on the sides of the truck over here where the height's 7.5, will the arch be too low for the truck to make it through? And so we know that the truck is 5 meters wide, so assuming it's going through the middle here, you have 2.5 on both sides. This middle point for the arch is 10.8. 15 is our x value here. So 2.5 to the left is 15 minus 2.5. 2.5 to the right is 15 plus 2.5. So what we really need to check is, what is the value of the arch height at these x values here? And in reality, we just need to check at one of the x values because the parabola should be symmetrical based on the way the truck's going through. And you can try it out with both values just to be safe, but you'll see that when we check with one, the value should be the same for the other. But again, I'll try it out for the 12.5, and you can try it out for the 17.5. So what we're going to do is we're going to go and plug one of these x values in to see what our height is of the arch. And then we'll compare to the height of the truck, which is 7.5, and see if the truck can clear that or not. So what we're doing is we're going to take our equation that we figured out over here, and we're going to go plug in one of those x values for the truck dimensions. So that's our third step, really, is plugging in that point to see if the truck will fit through. So we can do y is equal to negative 0.048. That's our a we found. And then we can do 12.5 minus 15. 12.5 minus 15 squared plus 10.8. And then we can just evaluate this to see what our y value would be. So you're going to get negative 0.048 times, so 12.5 minus 15 is negative 2.5, that'll be squared, plus 10.8. Put this in your calculator and you'll see you'll get, so we have negative 2.5 squared, 6.25, so times negative 0.048, you would show all your steps, plus 10.8. And so we would get a height of 10.5 meters. If you pause the video and try it with 17.5, you'll see you'll also get 10.5 meters. So what that means is that at 12.5, at 17.5, where the truck is spanning, the parabola has a height of 10.5. So basically here and here, we have 10.5 meters up. So now what you need to ask yourself is that 10.5 high enough for 7.5 meters? And it is. We know that 10.5 meters is larger than 7.5 meters. Therefore, the truck can fit. So the goal here was to first find the equation for the parabola, and then after we find the equation for the parabola, our next step was to see if the truck could fit by finding what points along the parabola the truck would span based on the width information provided. We found the height that parabola would be at at those points. We compared it to the height of the truck provided, and then we made our conclusion based on that. If this number, 7.5, was higher than 10.5, let's say it was 10.6 or 10.7, then our truck could not fit because our truck would be higher than that point and would hit the concrete at that point, or at those points. So that is how you would solve this problem. Again, in your solutions that I post online, there's a different method of doing it, but you'll get the same result, the same conclusion. It's just the parabola is placed at a different area on the grid. So we placed it on the negative axis as well, rather than starting from the 0, 0 point. Try that other method out as well, just to see that you have the right conclusion, and notice you get a different equation, but you still get the right conclusion. So go try that out to make sure you understand the process. This is more conceptual stuff here, so if you don't get the concept, it's going to be tough to understand what you need to do. So start out with that sketch, do the equation, and then solve the problem. If you don't do the sketch, the equation is harder to do as well. At least you have a visual to help guide you. Once you get the visual going, it makes a lot more sense. Before the visual, it's very difficult, even for someone's experience. So get the visual down first. Let's go to example 2. We're going to write a quadratic relation in the vertex form. There is a method to do that, but you didn't learn that yet. So what we're going to do is we're going to teach you a longer method right now, and then later you'll understand how to do the other method. So we want to write this in the vertex form and then sketch the graph. So right now we don't really have much in this form here. So typically if you're given the standard form, what I would want you to do is factor first. Factor using your factoring skills that we learned previously. So if we were to factor this, we would get y is equal to, open those brackets, x, what times what gives you negative 5, when you add it up gives you negative 4. Let's do negative 5 and 1. X minus 5, x plus 1. So now what we've found is our zeros. We have our zeros. Remember that for the zeros you switch the signs. So our zeros from this is we have 5, 0. And we also have negative 1, 0. So we found our zeros. Great. What we can do is we can also find our h value. So we can find h. Remember that the h value is the x value in between the zeros. So I'm going to go plot this right now. I have 5, 0, so here's 2, here's 4, here's 5, 0. And here is negative 1, 0. To find my h, I'm just going to add my two zeros together. So 5 plus negative 1, this is the formula on the first page that we saw, divided by 2 to find the in-between. That's going to be 4 over 2, which is 2. So right now I just found my h value. That means that my vertex is where the 2 is. What I can do is plug this h into my equation to find my k. You can plug it to any equation you want. You can do it this one or this one because they're equivalent to each other. So 3, we're going to find k by plugging h, which is the x value of the vertex, into your equation. Either the standard or factored form. You decide. So I'll do one form, you do the other, just to make sure you have the right answer. I'll do the factored form. Usually I would probably choose a standard form only because it's provided to you. If you made a mistake in the factored form, now you're making 2 mistakes somewhere. Now your mistake's carrying over, so I would probably go and do the standard form just to make sure. So y is equal to 2 minus 5 multiplied by 2 plus 1. I just replaced my x in there, which is going to be minus 3 times 3, which is negative 9. So my vertex is 2, and then negative 9 over here. And so there I have 3 points that I could use in order to draw my parabola. But I'm not done yet. I have to write this in the vertex form. So the vertex form, remember, is this. Y is equal to A times x minus h. We found h, which is 2, so x minus 2. So I'm going to write it up here. Y is equal to A x minus h squared plus k minus 9 over here. We need to find the a value. So for the a value, I can really use any point that I want that I have already. I'll probably use the any other point than the vertex here. I'll use one of the zeros I have. So for one of the zeros that I have, I could use -1, 0. So I'm going to plug that point in to find a. Find a with a using -1, 0. And so 0 is equal to a -1, -2 squared minus 9. I'm going to continue the work here. So 0, usually we continue underneath. 0 is equal to, -1, -2 is 3. Squared is 9, so 9a minus 9 is equal to 0. And then I'm going to do plus 9 here to get rid of the 9 on this side, and plus 9 over here as well. And so I get 9 is equal to 9a. Divide by 9 on both sides, and I get a is equal to 1. So now that I have my a and my vertex and everything, my final step is really just to write out the equation. Y is equal to 1. I don't have to put the 1 though, but I know it's 1, so I'm going to put it just for now just to show that I know it's 1. X minus 2 minus 9. And this is the equation in the vertex form for my parabola. Now, to draw it, I do have enough points, but I can use one more just to be more precise with where I'm going. Remember in the standard form, this is your y-intercept. And if you don't believe me, we can try that out. So to find my extra point to plot here, I'm going to do my y-intercept where x is equal to 0. So y is equal to 0 squared minus 4 times 0 minus 5. So y is equal to, everything here is 0, it's minus 5. So my y-intercept is 0 minus 5. I can go and plot that point in. So 0 here, and then minus 5 here. And I can use that to guide the drawing of my parabola. You can probably find another point if you wanted. 4, because the parabola is symmetrical, would also be at minus 5. 4 would also be at minus 5. See how this point goes to 0, goes down to minus 5? On the other 0 side, if you want 1 unit, you'd also go down to minus 5. So it's a visual way of doing that. If you don't believe me, you can try plugging it in. 4 times 4, that's 16. Minus 16, minus 5. So now you can just connect your dots here. It continues up this way. And there we've sketched the graph by hand. We found the vertex form. To do that, we had to factor first, find the zeros, find the x value of the vertex by knowing that it's in between the two zeros, find the k value by plugging that x value into the equation that we have, find the a value by using any of the points, zeros, to find the a value. Then once we had our a value, we were able to go plug everything in to get our final equation, and then I could connect my dots, and I found 2 other points just to make it more accurate. In the next video, we'll finish up with example number 3, an application problem involving quadratics.